So today we're going to go over two of the most popular logs you're going to use, which would be common logs and natural logs. Really nothing different with those two. Just they have a base that we use a lot. And then the do now, I just want you guys to do 1 through 5. Take 2 to 5 minutes. Pause the video and restart it when you're done. So log base 2 of 8, we don't know what it's equal to, so I'm going to say it equals x. Alright, so remember log base, if we want to convert this out of logarithm form into exponential form to see what it's going to equal. I think it's the easiest way about going about it. So our base is 2, our exponent is x, that's what we're trying to figure out, because remember a logarithm is the inverse operation to an exponential. And we're going to set that equal to the argument, which is 8. Now what we're asking ourselves is 2 to what power is equal to 8? Well, I know 2 to the first is 2, 2 to the second, 2 times 2 is 4, 2 to the third is 8. So I know 2 to the third is 8. So my answer is going to be 3. Number 2 switches it up a little bit. It says log base 8 of 2 is equal to, we're not sure yet, so put it equal to x. So our base in this case is 8. Our exponent is what the logarithm is equal to, which is x, and it's equal to the argument, which we put in exponential form, which is 2. So 8 to what power equals 2? Well, 8's getting smaller to get to 2, so we know it's going to be some sort of fractional exponent. We're going to have a root here, so it's going to be 8 root, and then square root of 8 is not 2, but the cube root of 8 is 2, and you'd write that as 8 to the 1/3 equals 2. So our answer would be 1/3. Another way you can go about doing this is you could think to yourself, try and do a thought bubble here. You could think to yourself, well, I know 2 to the third is 8, so how am I going to go backwards from that? 8, what would I do for 8 to get to 3? To get to 2 would be 8. The cube root of 8 would equal 2. And the last one, our base here is 2. Our exponent we don't know, so we'd say it's x, and it's equal to our argument, which is 1/8. So I'm going to tell you right now, I know this exponent has to be negative. Why is that? Because when you look at 2, if we're going from 2, which is really 2/1, to 1/8, this 2 is getting flipped to the bottom, and that 1's coming to the top. So I know that exponent, is going to have to be negative. So it'll be 2 to the negative something equals 1/8. And how do I go from 2 to 8? We did the past two problems. It's 2 to the third, so it'll be 2 to the negative third. So this logarithm would equal, log base 2 of 1/8 would equal -3. And number 4, think for a minute. Describe when you have used each of the following mathematical operations below. When you look at number 4, 2.4 times 10 to the 9th. If you remember this, back from 8th grade, this is, or really science class, this is scientific notation. And we use scientific notation. We use it to represent very small or very large numbers. Represent very large or small numbers. And that gets used a lot. Base 10 gets used a lot, not just for scientific notation. Base 10 with a base 10 and an exponent. This gets used also for, milliliters, centimeters, millimeters, centimeters, also meters. The whole metric system is base 10. So base 10 is a very common base to have a base of 10. And number 5, I don't know if we've seen this before, but it's something to be using a lot later on down the road. This is an equation for continuous compound interest. So when are you going to use this? This is used for continuous compounded interest. And that's used for like money. I'm talking interest on money. But you may not see this equation. You will be using it a lot in the future. And what is the base here? Our base here is E. Which we're going to be going over in a little bit. So our base here is the number E. It's not a variable. It's an actual number we'll be going over in a little bit. So what should I know by the end of the day? I can explain what a common logarithm is and why we use shorthand to write a common logarithm. I can also explain what a natural logarithm is and why we use shorthand to write a natural logarithm. And then there's 4 unique rules about logarithms. We're going to go over those 4. And you guys should be able to explain and justify each of those to its given value. So let's go to the next page. So if you read the top, since we frequently use 10 or e as a base for exponential expressions and equations, we give the logarithms with a base of 10 or e a special name. That's because we use them so much that we're going to use shorthand for them. Because they're the logarithms we're going to use the most. So, the logarithm with base 10 is called the common logarithm. And is written just excluding the base. So, log base 10 of x, we're just going to write as log of x. Because this is the most common logarithm, we do use shorthand and we don't even bother writing a base for this. Because when you don't write a base with a log, like log x, we're just going to say that is log with a base of 10. So I want you guys to look at number 1. Evaluate or estimate the following logarithms. So if I just have log of 100, let's evaluate log of 100. I don't know what's going to equal, so it equals x. And then what's really the base on log of 100? Well, if there's no base written, that's always 10. So that would be 10, if I put this into exponential form, to the x, because remember the logarithm is always equal to the exponent, equals the argument, which is 100. And then how do I get from 10 to 100? How many times do I have to multiply 10 to get to 100? That's 10 squared. So I know log of 10 has to equal 2. And we'll look at log of 350. So if I look at log of 350, we don't know what it's equal to, so I'm going to say it's equal to x. My base is 10, so it'll be 10 to the x equals 350. Well, I know 10 squared is 100, and I know 10 to the third is 1,000, so I know it's going to be in between. My exponent's going to be in between 2 and 3. I'm just going to say x is going to be about 2.5. That will be my estimate. But you can always check in the calculator. So you can always press log of 350 in your calculator. And I want to show you guys how to do that. So in your calculator, let's get back to the calculator. You just want to press, you see where log is here. You don't have to go to log base. The log button next to the 7 is just the common log with base 10. So that's why they have this button here. It's the most common log. So it'd be log of, we can check the first one, which would be log of 100. We should get 2, which was our answer. We get 2, awesome. And then on log of, we'll check the next one, 350. And you get 2.544068044. So the estimate of 2.5 is pretty close. So that's the common logarithm. Nothing really new with that from yesterday. It's just the base is 10, and we write it a special way since we use a base of 10 so much with exponentials. So that's the common log. There is also the natural log. So a logarithm with base e is called the natural logarithm, and is written with, instead of log, it's written with ln. So that stands for the natural log. And I know you're asking yourself, what is this e, and where is this coming from? So e, it's called Euler's number. We're not really using it that much this year. You'll see it used a lot when you take pre-calculus with a continuous continuously compounded interest and other things. But yeah, you'll see a lot of e being the base and some exponent, we'll say is x. You see a lot of e to the x going on. So naturally, since this is a common exponential, e is going to be a common base, so that's why we give it a shorthand, which is the natural logarithm. So log base e of x is equal to ln of x. So whenever you see ln of x, you just know that means log with a base of e. So, and if you're wondering what e is equal to, just go to your calculator. We have a button for e. If you look at the divide sign, there's an e right there. That is e. So it's a number just like it's an irrational number like pi, like radical 2. Just press enter. And that's what it is. Be careful, it's not rational. It does not have a repeating. That would keep on going on forever. The calculator just is rounding it because the calculator rounds to 10 places. So that's what e is. So I just want you guys to use your calculator for 1 and 2. We can just do them together. So 1 is ln of 9. So ln of 9, if you look right under log, the common log, it has ln, a button for ln, which is a natural log of 9. So that would be we'll round it to like 2.2. So this would be around L of 9 would be around 2. We'll write the whole thing. 19722457734, and we'll do the same thing for ln of 64. So ln of 64, that is equal to ln of 64 is equal to 4.158883083. Unless it tells you to round, you don't want to round. This is not telling us to round, so we'll just leave it as the whole thing. I know the calculator's rounding a little bit, but that's the best we're gonna be able to do with this. Round it to the nearest, you're writing with 10 spaces, so 10 digits, I should say. So that's the natural log. We're gonna be using natural log a lot because we use e as the base a lot for exponential equations and expressions. So on the next page, we're going to be looking at special properties of logarithms. Today, you're kind of going to be discovering them for yourself. So I want you guys to simplify 1, 2, and 3, and then generalize your findings of log base a, where a can be any number. Remember, a has to be greater than 0, and a cannot equal 1. So any number that fits those parameters. So log base a of 1 should always equal a certain certain value. So I want you guys to pause the video, do 1, 2, and 3, generalize your findings, and explain why this is true using correct and effective mathematical vocabulary. So number 1 says log base 8 of 1 equals, we don't know yet, so I'm going to set it equal to x. So my base is 8. My exponent we don't know is x. That's set equal to 1. How many times 8 to what power gives you 1? Well, the only thing we could do here is 8 to the 0 power. Remember, anything to the 0 power equals 1. So our correct answer here for log base 8 of 1 would be 0. Let's check number 2. Number 2, very similar question. Log base 36 of 1. We don't know what that's going to be, so we can set it equal to x again. That would be 36 is our base. Our exponent is what's equal to, which we don't know, which is x. Set it equal to 1, which is our argument. 36 to what power equals 1? Well, anytime you raise any base to 0 power, it's going to equal 1. So this would also be 0. And then let's look at 3, log base x of 1. I don't know what this is going to equal. I'm not going to set equal to x in this case because we already have x in the base, and that'd be saying the base is the same as the exponent, so I need to set up to a different exponent. I'm going to use y. So that'd be x to the y equals 1. If it's going to be equal to 1, we know our exponents have to be 0 again here. So you might have seen the pattern here. If we were to generalize our findings, log base a of 1 is always going to have to equal 0. I want you guys to take a second if you haven't done this yet and explain why this has to be true using correct and effective mathematical vocabulary. So what I said is when a number raised to an unknown exponent has a solution of 1, well, that exponent has to be 0. And I bet along the same lines, but a lot of you guys might have said this also, any number raised to a power of 0 is equal to 1. So if logarithm's looking for the exponent, well then the exponent would be 0 in this case. So we're going to do same thing here. I want you guys to do 1, 2, and 3, then generalize your findings. Take about 2 to 5 minutes. Pause the video. So log base 2 of 2, remember logs are trying to find the exponent, so it's the unknown. So our base here is 2. Our exponent is unknown, which is what we're trying to find. Remember, that's x, or any variable you want to make it. So 2 to the x equals our argument, which is 2. So 2 to what power is going to give me 2? Well, 2 to the first is going to give me 2. And let's look at number 2. So same thing here. 12 is my base. My exponent is what's unknown because we got to evaluate the log, which gets the exponent by itself. We set it equal to our argument, which is 12. So 12 to what power is going to give me 12? Well, that is, again, the first power. And how about any value of x? So I'm going to set this equal to y. So that would be x to the, I don't know what power, y, is equal to our argument, which is x. Again, how x to what power would give you x? Well, that would have to be the first power again. Because whenever you raise a base to the first power, you just get the base. So if I was going to generalize my findings, log base a of a, so when your base is the same as your argument, what is that always going to equal? That's always going to equal 1. And here's what I said for my explanation. I said when a number is raised to the first power, the result is always that same number, which is the base. And just an example, like the example we had up there, 12 to the first is equal to 12. So those are two special properties of logs, and we're going to do two more on the next page. So on the next page, what I want you guys to do, very similar to the other two, is I want you to simplify 1, 2, and 3, generalize your findings, and explain why this is true using correct and effective mathematical vocabulary. Take your time. This should take 2 to 5 minutes. Same process, convert from log to exponential, see what happens. Pause the video if you haven't. So, for number 1, says log base 4 of 4 to the 5th. So, in this case, our argument, which is 4 to the 5th, that has an exponent on it. So, if I were to convert this, we don't know what it is off the top of our head, so I'm going to put this log and I'm going to set it equal to x. So, if I put this in exponential form, that would be our base is 4, our exponent, which the log is equal to, we don't know, we said it was x, is equal to our argument, which is 4 to the 5th. So, we're trying to figure out what x would be. And if I check out, so 4 to the x equals 4 to the 5th. So if 4 to the x is equal to 4 to the 5th, then I know the exponents, x and 5, have to be equal to each other. So x is equal to, has to be equal to 5. So our logarithm, log base 4, 4 to the 5th, has to be equal to 5. Let's check out number 2. Number 2, similar question. I don't know what it's going to be equal to. Something that's equal to x. Our base on the logarithm is 9, so that's my base and my exponential. My exponent is x, and that is equal to the argument, which is 9 to the 3rd. Now, if 9 to the x is equal to 9 to the 3rd, we have the same base, so we know our exponents have to be the same. So x in this case has to equal 3. So log base 9 of 9 to the 3rd has to equal 3. And look at number 3. So log base c of c to the d. We'll set it equal to x. So we know c to the x has to equal the argument, which is c to the d power. So we know we have the same base. So we know the exponents have to be the same. So x has to equal d, so log base c of c to the d power is equal to d. So if we go to generalize our findings, log base a of a to the x, so the way I look at this is if the base of our logarithm, which is a, is equal to the base of our argument, which in this case is also a, then our logarithm simplifies to just what the exponent is, which in this case, or the exponent on our argument, which in this case is x. So let's explain why this is true. I said if the base of the logarithm is the same as the base of the argument, then the logarithm is equal to the exponent of the argument. You could also think of it as, this is also how I think about it, is if you think about it, hold on a second, I don't know why argument just erased there. There we go. So if you think about it, log base a and a to the x are inverse operations. So if they're performed on each other, they're just going to end up canceling out. Woo! And we're left with just the exponent, which is x. So that's how I like to show my work when we do more of these. They just cancel out, cross them out. Where's left with x? So that's our answer. So what I want you guys to do now is scroll down. And I want you guys to do, this is the last one, I want you guys to simplify the following logarithmic expressions. And try to come up with the rule for this. pause if you haven't. It should take like 2 to 5 minutes like the other ones. So I think this one's a little trickier to see, but it's the same exact process. So instead of being in logarithmic form, you want to kind of look at this as being an exponential form. So if I were to look at this, what's the base on my exponential expression right here? It's 3 for number 1. The exponent is a log, which is weird. We haven't seen that yet. So our exponent is log base 3 of 7. And then my argument, what it's equal to, well, we don't know what that is, so we're going to set it equal to x. Okay, so now I'm actually going to take the exponential form, and I'm going to convert it into its equivalent logarithmic form. So that would be, if I take a look at this, log, and then our base here is the base on our exponential is 3, so that's our base on our logarithm, 3. It's equal to our exponent, which our exponent in this case is a logarithm. It is log base 3 of 7. And then our argument, which is x, goes there. So, if I look at this, it says log base 3 of x is equal to log base 3 of 7. We have the same bases on our logarithms. We have the same bases, which are 3. So we know if we have the same base, then the x and the 7 have to be equal. So the x and the 7 have to be equal. So what is log 3 to the log base 3 of 7 equal? Well, that equals, well, that we said that equaled x, which has to be 7. So that would be 7. If you do the same thing for number 2, number 2's, if I convert it out of exponential into logarithm, number 2 would be the base here of my logarithm is going to be 9. The exponent is log base 9 of 20. And my argument, I don't know what that is, so we're going to say it's x. We both have the same base in our logarithm, which is 9. So x is going to have to equal 20. Which is just, so also 9 to the log base 9 of 20 is equal to x, so that would be 20. And number 3, we would do very similar. So c is our base. If I take this out of logarithm form, that would be log base c. What's that equal to x? It's going to be equal to our exponent, which is log base c of d. And our argument goes there in our logarithm. So what does c to the log base c of d have to equal? Well, it's x, which is equal to d, so it equals d. If you generalize your findings, then if I have my exponential base be a, and I raise it to a logarithm with the same base as my exponential base, in this case is a, what is that going to equal? Well, that's just going to end up equaling whatever the argument is, which in this case is x, with that logarithm. So explain why this is true. What I said is if a number is getting raised to a power that is a logarithm with the same base, then the expression is equal to the argument of the logarithm. And the reason that is it's very similar to the one above. A to the x and log base a to the x are inverse operations, so they would cancel each other out. So I would just cross these out. It's kind of like adding 2 and subtracting 2. Those are inverse operations, so they cancel out, and what's left over is the argument on the logarithm, which is x. So those are the 4 rules of logarithms that we're going to go learn today. I want you guys to go on to the next page. So on the next page, this is putting everything together, all the rules we just learned, discovered, and also the common and natural logs. So I want you guys to do 1 through 10. If you want to listen as I go through 1 and 2, just to give you guys a little reminder, feel free. So pause the video now if you want to just do 1 through 10. But keep listening if you want to go over 1 and 2 and then do 3 through 10. So number 1, log of 1. Remember log? If it's just written as log, what's the base? This is the common log. That's really log base 10. You right there if you want to. We're going to be using this a lot where you're not going to need to do that after a little while. So we don't know what's equal to. What's that equal to x? So log... Oh, why am I writing log? I don't need to do that. So that would be our base is 10. Our exponent is what it's equal to the x is equal to 1. 10 to the x, what does x have to equal in order to have it equal to, have the expression equal to 1? Well, x is have to equal 0. So you can also write as log of 1 is equal to 0. And then similar, ln, remember ln has a base of e. You can write that there if you want to remind you. Once again, we're using a lot where you don't have to write it, and it won't be there. So I'm going to set that equal to x. So that would be my base is e, my exponent is x, and my argument is 1. Well, e to what power is going to give you 1? E to 0 power is going to give you 1. So ln of 1 is equal to 0. So that's it for 1 and 2. Pause the video here and try 3 through 10, and I will show you the answers for 3 through 10 in a couple minutes. Take your time, 2 to 5 minutes. So here are the answers. 3 and 4 should each be 1. And then 5 and 6. I want to show you guys what I like to do with 5 and 6. 5, 6, 7, 8, 9, and 10. Because we are performing inverse operations, you could show it like this. This is fine, but once you get used to it, this is what I like to do. So let's take example number 5. Log base 10 of 10 to the x. Those are inverse operations, so they just cancel out. And you're left with the exponent, which is just x. So that's why our answer is x. You can do the same thing with 6. Natural log of e to the x. ln and the e cancel out, and you're just left with x. And you can see I did that with 8 and 9 too. Sorry, 9 and 10 too. So that's it for today. If you look at the next page, I have the success criteria. I would recommend going through this to make sure you are good with today's lesson. And then the classwork is after this. That's it.